This is the example video for using relative frequency, unit 16.3 on page 155. It's the last one of the probability section, so we'll be doing this and then moving on to what's next. Bearings and scale drawings. But for now, I'll just go through this. So, what is relative frequency? I think we did a bit of this last year, but you probably don't remember. Relative frequency, it's when we don't know the probability of something. So we don't know, we don't know the probability. So what we do is we do an experiment. And you test it over and over again, and you get a set of results. And you put them in a table usually. So obviously when you're in the exam you won't be doing this experiment and getting the results. If we were in class then we could have done it, but obviously we can't. So you do an experiment, you get some results, and from those results you estimate a probability. So we'll see how this works in a moment when I do the example, but this is the general idea. We don't know the probability, so we do an experiment to try and find it out, and we get an estimate. So the more experiment we do, so the more tests we do, the more accurate it's going to be. So if we just do, so the example in the book is throwing like a pin and seeing if it lands point up or point down. So if we just do that once and it lands point down, then you say, oh, it's always going to go point down. But obviously that's not very accurate. But if you do it 100 times, you start to see what probability it will actually be. And if you do it 1,000 times, it's getting more and more close to the real probability. So let's do an example and see if it makes a bit more sense. So we have here, Elsa is throwing a ball as hard as she can. The table shows the distances. Then we have this table here with distance and number of throws. So this means the distance is less than 20. The distance is between 20 and 30. Distance between 30 and 40. Distance is less than distance is greater than 40. 40 is less than the distance. Okay, and we have the number of throws. What is the probability that the next throw will be between 20 and 30? So we obviously don't know the actual probability how far Elsa's going to throw the ball. So we've done, this is like the experiment. We've got our results, they're put in a table. So now we have to estimate the probabilities. So our best estimate is just using this table. So between 20 and 30, well, that's this one. Between 20 and 30. So it's 14. But 14 what? Well, how many throws has she done? She's done 6, 14, so that's 20. Add 23 is 43. Add 7 is 50. So we could have a little total column with 50. So she's done 14 out of the 50 throws have gone that distance. So that's the probability. We just say that it's that. And we can put it as a decimal. Maybe it's a bit better. So there you go. That's all it is. So now let's look at B, more than 30. So now we just look more than 30. Well, this is less than 30. So this one's more than 30, and so is this one. So both of those are more than 30. So we have 30 of them, 23 and 7, out of the 50 are more than 30. Okay, so we're just taking the ones and using it to estimate. And now let's look at orange. Between 20 and 40. So this is less than 20. So this is 20 and 30. 30 and 40. That's too big. So it's 14 and 23. So 14 add 23. Out of 50 still. So what's 14 add 23? It's 37. And we can put it as a decimal. I think that's right. Yep. And that's it. That's all this is. So it's quite straightforward once you know how to do it. They might ask you to do 2 different people. So there might be another table with someone else throwing the ball, and it'd ask you whose who can throw it further or something like that. You've just got to compare the probabilities and make your own conclusion. Sometimes, I'll show you something else, sometimes it does all this, and then it would say, it might say Elsa throws the ball another 10 times, and she gets all of them over 40. So let's write that down quickly. Oh, just rubbing out. So she throws the ball another 10 times, 10 more times, and gets more than 40 each time. So that would mean this now is 17 and this is 60. Okay, what's the probability of getting, and then we can choose a section, well, let's say less than, let's do one we did before, so between 20 and 30. Well, it's still 14. Still 14, but it's out of 60 now. So 14 out of 60. And we can make that into a decimal. So 14 divided by 60 is 0.23 recurring. So the probability's changed because we've got new information. And which one's better? Is this one better? Or was the 0.28 better? Well, this one's better because it's newer, we've got more information, we've got more trials. So this one's better. And that's the topic, really. So if you have any questions, you can comment on the video or you can message me on Google Classrooms. But that's it. So that's the work for today, pages 155 to 156. You can do the brains as an extension, so you should be trying to do that if you're finding it easy. And then we've got homework again. So it's to hand in on Friday, and it's going to be the end of unit. And I want you to do all the questions because there's only 5 of them. So there's 2 brains in there, but I want you to try them anyway, all questions. I'm going to make the assignment on Google Classrooms. So try and get it done before Friday, and message me if you've got any problems.